Welcome to Maviintelligence. So in this video, we are performing fabric texture analysis program where we capturing the original fabric texture data, then we comparing that data with other types of fabric materials. Also, I'm providing a different kind of tool which helps to find out their qualities. So stay tuned with Mavi. Follow all these steps and instruction according to my guidance. Now without wasting our time, let's jump to the coding section. Import all the necessary module for fabric texture analysis program. So here we need 5 modules. Now write a command. First module we need a OpenCV library. So just write a command for that thing. Import CV2. Then second we need a NumPy library for working with arrays. So just write import NumPy as NP. Third, we need a matplotlib library. So just write import matplotlib dot pyplot as plt. And the fourth one, we need a Mavi library. So you guys get Mavi library with the source code. So write import Mavi. And the last one, we need a texture recognition function called local binary pattern. So write for that thing from sk image dot feature import local binary pattern. Let's set the matplotlib inline term matplotlib inline. Now let's run this command. Okay, it's not successfully done the importing part, so that's it. Here we are extracting the texture data from original fabric material. So just write a command. First we have to load the fabric original fabric image. So just write fabric. So I'm taking variable fabric image equal to cv2 dot I am read. So name of the command, name of the image, fabric image, it's fabric 1.jpg. Also I'm applying a grayscale color model. So cv2 dot I am read grayscale. Also we need to gather that dimension. So just write height comma width equal to fabric image dot shape. Second, we have to extract the texture data from fabric image. So just write a command. So first I'm taking a variable called fabric texture equal to local binary pattern. So it's take 4 arguments. The first argument fabric image name, so fabric image comma. Second argument number of texture points. So for that thing I'm creating a variable total points. So I'm taking number of texture points 16. So total points. Third argument texture point radius. So for that thing object radius equal to 8. Object radius. Now the last argument we have to set the method equal to uniform. So when you're getting done with the gathering the texture data, we have to normalize the data in terms of histogram. So for that thing, just write texture data comma underscore equal to np dot histogram. So it's take first argument fabric texture, second argument I'm setting the density equal to true, third argument bins. So for bins, total bins equal to int in the square bracket, sorry, in the bracket fabric texture dot max plus 1. So total bins is around total number of fabric texture points plus 1. So let's implement that total bins here. Now the last argument in histogram, we need a range. So for the range 0 comma total bins. So normalizing data, it's getting completed. Now the third, we have to visualize our result. So figure comma axis equal to plt dot subplots. Okay, so first set the n row. So I'm taking n row 1, and the second number of columns I'm taking 3, and the third argument figure size. So in figure size, width divided by 50 ratio comma height divided same 15. Let's set the axis 0, set title original fabric, then say, on axis 0 we have to show our original image. So axis 0 I am show fabric image. Now on axis 1, let's set the title first, grayscale fabric. Let's set the on axis 1 we have to show the fabric image in grayscale. So fabric image comma cmap equal to gray. Now on the third axis I'm plotting a fabric texture image. So axis 2, set the title texture image, then axis 2 I am show, so here fabric texture, okay, fabric texture comma I'm taking cmap equal to gray. So then the texture image converted into a grayscale format, and the last plt dot type layout. Now code is completed. here. So let's run this code. Now if you see on the left side our original fabric image, in the middle a grayscale image of our fabric, and on the right side our texture image. So that's it. In this step we have to grab the texture data from a testing fabric material. So why we need testing fabric material? Because we have to compare the texture data with original fabric. So now here we have to repeat the same process, same as original. Now write a command test fabric equal to cv2.imread, first argument name of the image fabric2.jpg, set the grayscale flag cv2.imread grayscale. Now we have to grab the dimension, so height comma width equal to test fabric dot shape. Now the second we have to grab that texture data. So grabbing the for accessing the texture data, test texture equal to local binary pattern. Now let's take first argument test fabric. Now second argument number of texture point, total points. So create that variable total points. Okay, total points equal to 16. Third argument object radius. So create object radius equal to 8, comma. Now last method. So method equal to uniform. Okay. Now let's normalize the test texture data in terms of histogram. So test underscore data comma underscore equal to np dot histogram first at the test texture. Now set the density equal to true, comma, then set the bins, so total underscore bins. Create that the total bins variable, total underscore bins equal to int test texture dot max plus 1. Now the last argument set the range for text histogram. Set the range for histogram 0 comma total bins. Now the last step we have to show all those fabric images. So write fig axis, okay, equal to plt dot subplots. Now in subplots number of rows equal to 1, number of columns equal to 3, then figure size, width divided by 15, 50, and height divided by 50. Now set the values on axis 0, set title test fabric for the value X is 0. I am show test fabric. Now X is 1. Grayscale of fabric. Now set the value for X is 1. Test fabric comma cmap equal to gray. X is 2 dot set. Now set the title. Here we have to set the setting the title texture data of fabric. So X is 2 dot set, not set titles. I'm show. Here we have to show test texture comma cmap equal to gray. Now the last line plt dot type layout. So let's run this whole code. So you guys can see on my left side a test fabric image, and middle a grayscale of fabric, and on the right side a texture data of testing material. So that's it. In the last step, we have to compare the testing fabric material with original material. So we need a Mavi texture analyzer tool which helps to compare both the texture data. So let's write a command Mavi dot texture analyzer. So first argument, it's original texture, which means we have to set original fabric texture data, so texture underscore data. Second argument is test texture, which means we have to set the testing fabric material data, so test data. So command is now completed. Here let's run this. Here we got the higher value. So if the error rate, which means this value, if the error rate is high, which means the fabrics are not matching, that conclude that the fabric are not made up of same kind of material. So if the value is greater or equal to 1, which means fabrics are not matching and they are not made up of same kind of material. If the value is less than 0.1 or 1, okay, which means fabrics are made up of same kind of material. Okay, so I'm showing one demonstration of how fabrics are matching. So I'm taking fabric 3 image. So let's run this thing. So you guys can see it's a fabric of jeans material. Now let's run this texture analyzer one more time. Okay, we got value around 0.8, which means fabric 3 and fabric 1. Our fabric 1 is our original fabric. Okay, so fabric 1 and fabric 3 are made up of same kind of materials, and fabric 2 are not part of this. So that's it. Here you have now successfully completed the fabric texture analyzer program. For the code instruction, get the link from description and let me know in the comment box what kind of industrial projects you want me to make in the future. Till then, try to make your own system with the help of Maviintelligence, and I will see you in the next video.